This presentation will be about 40 minutes with a 15-minute Q&A at the end. And the purpose of this is to allow the IAC community to communicate with each other, share ideas, and it's the purpose of bringing everyone together today. A quick plug for our next webinar. It will be held in January. It will be presented by the Assistant Director from San Diego State University about the role of 15-minute utility data in IAC recommendations. On to today's presenter, Joseph Ghislaine from Compressed Air Challenge will be presenting on IAC FAQs on compressed air systems. So Joe, you should be able to share your screen now.
And just to prime the conversation for Joe, if you guys remember a few months ago, there was a exercise that we got all of you involved in generating questions that we had around compressed air systems and controls. So what we did with Joe is collected that information, shared it with him. And the idea is today's talk is about, some of the things that you guys had highlighted in your Q&A that we posed to him, but feel free to jump into the conversation as Joe takes us through the response back, and also resources available through compressed air system challenge, compressed air challenge. So I'll hand it over to you, Joe.
Okay, great. Let me go ahead and start sharing. Hopefully everybody can see my screen. Okay. Well, thank you, everyone. I appreciate the ability to come in and have the discussion with you. We're going to go a little bit. Many of you know about the Compressed Air Challenge, but I just want to go through and highlight some of the Compressed Air Challenge and some of the changes over the years that's happened. What we want to go through and do is we've had a good relationship with DOE's sponsored Compressed Air Challenge since it was developed over 20 years ago. And we've done training in the past with IACs, and a couple of the IACs continue to do ongoing training. But we just want to, again, make you aware of the resources and what may be available in the training there. So the first part of it's going to go through Compressed Air Challenge training. And when I got a lot of the frequently asked questions, it really kind of hit me that when we go through the Compressed Air Challenge fundamentals in advance, that we really go through and we answer those questions. So again, just to kind of ground everybody as to some of the changes and updates we've made over the years, especially since DOE stopped funding the Compressed Air Challenge training, which was back in about 2011, 2012, when they weren't hosting as many of the trainings. So let's go ahead and get started with the presentation. So just a little bit about me. I've now got my own consulting company, but I've spent 31 years with Ford Motor Company, and then I've had 40 years plus experience in compressed air systems, powerhouse maintenance, energy, operational efficiency improvement. I've been on the part of the Compressed Air Challenge as the end user representative since its inception. And I'm a level 1, I'm a fundamentals and advanced instructor and a board member. I also have a number of other energy certifications, including the KGI's new certification on compressed air system specialist. So I do have a fair background in not only compressed air, but energy in total. So Compressed Air Challenge, it's a nonprofit voluntary collaboration of the folks you see here. It really was getting the stakeholders together and bringing them together so they have one purpose in mind. So again, it was the end users, KGI and the representatives, the distributors, consultants, energy efficiency organizations, research groups, DOE, and utilities. And really the main thing that the Compressed Air Challenge has is to go through and provide end users with the knowledge to improve the compressed air system that they have. So it's really about the efficiency and looking at it from a systems approach. Why do we care? Again, in the U.S., it's about $5 billion in energy costs. Many of you already know this, and it's part of your IAC when you go through and do your audits. But just as a reminder, it represents 10% of the electricity used in North America and 16% of all of the motor systems. So it is a fair amount that compressed air uses. And really, it's not free. If you talk to the people in production and in plants, they don't know, most of the time they don't know the cost. They think it's free, but it's not very efficient neither. This just shows an indication of, for every horsepower of useful work you have to put between 7 and 8 horsepower into that. This shows 7.5 on the left side, and you can see in the blue that useful work. You got the first, the input power losses that you have, but then you have all of the losses in the system, including heat of compression, which is a huge loss in the system, because compressed air, as you know, compressors aren't very good at compressing air, but they make great heaters, and you got to get rid of that heat. So just to kind of a little bit of the cost on it, it can run anywhere from 18 to 32 cents per 1,000 cubic feet. The auto industry, where I come from, it can be a significant part, ranging from 10% in the components to up to 40% in stamping plants. Often you can find 20 to 30% leaks, sometimes as high as 50%. And in Ford plants, it can cost anywhere from several $100,000 to millions of dollars per year for compressed air. So training, it really solves the problem. So the compressed air challenge has multiple levels of training. Again, it's for the maintenance plant engineers. We have fundamentals advanced. This also goes for systems folks. We have the more advanced system specialists, the qualified air master. We also have an end user operator awareness training. And then coming soon, we're going to be having one on building projects and justification. The other resources we have is, of course, the best practices manual. And we also have a lot of on the CAC website, a lot of case studies, articles, fact sheets, the DOE CAC source book that we work on updating with DOE. So those are all available as well. So again, it's a nonprofit, and what we try to do is go through and educate people on compressed air. So just real quick, you guys, the two main ones that I want to touch on are the fundamentals and advance. The fundamentals is an introductory. It really goes into calculating the energy costs and efficiency. So you can see all the things it is. And again, establishing a baseline, looking at the inappropriate uses, finding and fixing leaks, and understanding the controls. So again, it really is about going through and looking at it from the perspective of the system. And in advance, we got a 2-day that we get into much more detail on collecting data, what to look at, how to develop the profiles, maintenance programs, all of the things that address quality and air issues, especially when you're trying to reduce pressure, control strategies, supply and demand, heat recovery, and then also selling the actual to management, which becomes a very important thing when you're in a plant and facility. So just a little bit, you guys, I know many of you have done training for fundamentals in advance, and that's kind of a review, but I just want to kind of do an update on what we've updated on our training. And the fundamentals we've added over the years, we've added the VSDs, looking at the pros and cons and how to actually do leak load identification with VSDs. Enhanced controls, sequencers have come into play, strengthen the compressor types in the appendix and handouts. So the other type of rotary compressors that aren't the rotary screws, we go through those and we mention them in the training, and there's a handout that's more detailed. We've also, to go through, make it a little more international and usable, we've included SI units in it, and we also talk about the KGI data sheets when we were in the class. The advance, we really have gone into more detail, and some of that was highlighted in some of the questions that you guys sent in to ask about. And really, we look at the VSDs, looking at the control back, the actual control gap, going through an expanded control and handouts, how it goes through and in the handouts, we've also included, kind of the differences in the most common installation issues that we've seen. So it really does enhance that. We redid this. We actually added a centrifugal section. I wasn't happy with the way we treated centrifugals, and I spent a lot of my time at Ford with centrifugals. So we went through and we've updated that and actually put in a whole section on centrifugals and how they work and issues there. We've updated the quality standards to the new ISO standard. You know, and there is an artificial demand, how to calculate artificial demand handout that we've put in the back of the advance as well. So these are the major ones that are done, you know, that have been updated, along with some of the minor stuff that we've gone through and done. So the other thing I want to touch in is, many times people say, why do we do training? Especially we get that questions with working with utilities. How do we know it's going to save energy? How do we know it works? And even somebody that has to talk to their boss about going to the training, you know, what am I going to get out of this when I go through and, you know, send you to a training and pay for it? Well, this was the original DOE study that was done that showed that, you know, that the training was very effective. You know, you can see you know, the details here. 76% of the end users use the material to actually go implement when they followed back up. You can see that it was 149 megawatt hours, or 7.5% of the system. And when we talk about the yield and the benefit ratio of the training, it was about $82 for every training dollar spent. So it really has been, you know, effective training, and continues to be. And, you know, since we were formed and started doing the fundamentals in '99, we have trained over 20,000 people in compressed air systems. So again, we've had a good outreach on it, and we continue to go through and have success with the training. A little more updated one, we worked out with some of the utilities that have done the training, and these are examples of utility programs, because again, utilities will ask, well, if I put on training, what do we get out of it? And it would be same for the IACs. You know, if we go through and do this in conjunction with, you know, with the company, or we send our engineers that we have that we go in the field, you know, what do we know? How do we know that they're gonna really be able to do something and get something that's worthwhile in learning? So this is a couple of examples. The focus on energy one. They had a follow-up survey with 3 of the different companies that were attended. 6 projects were completed. The savings for the projects were between 20 and 280 kW. Again, 50, the program value, which is the way utilities look at it, was about 53,000 for them, for just going through and, you know, again, hosting that training. Efficiency Vermont had some similar stuff that they had. They followed back up with a couple of their customers that they had at a training, a paper company and a cheese company, and you can see the results there. That was about 150,000 kilowatts per year, and a program value for them of about 23,000. And then the big one that Ameren, Illinois, these are all on the fundamentals now. This doesn't even get into the more advanced stuff. They did 3 fundamentals training events, and what they did is they combined it with a marketing scheme that they had, where they could go through and have the efforts of the opportunities in industrial sites and broadcast it. So you can see they targeted 270 facilities within the 100 miles of the training sites. They would go through and do the email blasts. They were able to capture 57 attendees representing 47 facilities. And then they would follow back up afterwards. And they had some really impressive results on their utility program. This is just the activity that they had. The direct applications were 25 applications from there at 6.4 million kilowatt hours. And you can see the value of the program there. The other one that was really astounding was the indirect impact. This shows the impact of both kilowatts and the applications they had both prior to and after, you know, the compressed air challenge. So if you look at the little graph there, the orange is when they were doing the training and doing the email blasts, and the other is historical, before, you know, just prior to and just after. So again, it was a big boost to it. So the reason I want to go through and point this out is that the CAC training is action oriented. It really is meant to apply the best practices and use a systems approach, and walk away, have the person in the class walk away with something. And this just for those of you that have been in it, you might recognize it from it when you took it. But this is just a combination of the 7 and 8 step action plan. Fundamentals has a 7, and then we build on it in advance for an 8-step one. This is just kind of combine it, but you can see it really talks about going through and looking at the block diagram and understanding your baseline, and then all of the things with controls and preventive maintenance and looking for inappropriate uses and leaks and identifying high points. So again, it's all about supply and demand, and many of the things that you would be looking at and looking for when you would be going through and auditing a company as you walk through on your energy audits. And I know that I know that your audits are all encompassing with energy, which is why it's also good to understand and know the demand piece of it, because many times you may not be able to do a lot of the metering and monitoring that you'd want to do if you were doing a little bit more in-depth compressed air audit. But from an actual energy audit perspective, this would still be able to give you results that you could go through and achieve. So again, the systems approach really covers the whole, covers the whole thing, from training and awareness, which we feel is really important, and then baselining, and of course, keeping that aligned, the supply with the demand, controls, which we'll talk more about, maintenance, design, and that demand, also the demand side strategy. Really important is to publish the savings and that employee involvement, continual improvement, and then trying to go through and integrate it into current processes. So making it something that a company does as part of what they do rather than something additional to what they do. So to the questions. So I'm gonna now quickly jump into the questions that you had for, again, for going through and doing it. So the first ones were, on baseline energy calculations. I kind of grouped these as we go through. Now this is going to be kind of a combination of what I would do in class, which is answer the questions straight out, and some of them I do have some slides to go through and actually talk about that as well. So the first one is, can a simple field test be used to estimate the compressor's annual power consumption, or 75 load at 90% as good as we can do? That's a great question, because the 75% and 90 is really a kind of a industrial ballpark average. Some of the things you may be able to do is, if you can go through and do spot checking, obviously to be able to have a KW meter and even a flow meter, and be able to put it on, and actually go through and actually do some data logging would be ideal. And I know that isn't always the case. You may be able to go through and look at what the load unload characteristics are, or even if it's in modulation, if you go through and just take the currents and the amps, you may be able to get an idea of what that is. Another thing you can go through and look at with load unload machines is look at over time, how much is loaded, how much is unloaded. And you can then do the calculation of what the loaded percentage would be for the cost versus the unloaded piece of it. So that's another way you could go through and look at it. Sometimes talking with the operators on, what they actually are running and how they're running them, and what they have shut down on the weekends, they may have a good idea and an indication that you can also go through and use. So there's several different ways you could look at going through and doing it. Again, being able to measure it is going to be one of your most effective ones that you would go through and have. Okay. So how to measure mass flow on a day of the audit? Often you're looking at the performance. You want to go through and understand. They don't have a historical. And this was going through and asking about logging and being able to do non-invasive. You still, the hot wire anemometer type insertion is probably still going to be the one that's probably going to be as long as it's temperature compensating, going to be your best bet. That does require a hot tap and putting it in. So I did also reach out to one of my fellow instructors. That's the nice thing about advanced and having two instructors when we do it. One of the things that's out there is ultrasonic flow meters, and those originally weren't as accurate unless you got into high pressures. Well, they've made a lot of improvements since then, And normally we don't, in compressed air challenge, we wouldn't go through and do any, it's product neutral, but I had a feeling that you guys would want to ask the question of, okay, if they're out there, is it something we can go through and use? And there are some ultrasonic flow meters. These are two of them that that have been, that Frank Moskowitz, my, again, my friend and instructor, I reached out to him because I knew he had done some benchmarking look at this to go through and compare those to an actual hot wire anemometer, and he's found these two to be to be pretty accurate and reliable. So again, this clamps on the outside of the pipe, and it does not require any intrusiveness. The cost I'm not sure of, so it might be something you just want to go through and rent. That's what he said that he does. But I did want to make let you know that these are available, and there is something that we can go through and use. Calculate system from a multi-system site. Yeah, this can be difficult. What I would suggest on multi-compressors is when you're going through and measuring them, going through again, if you can data log them, it's the best bet to get all of them to sync up at the same time. Another way you could go through and do it is if you have multiple compressor to load unload, if you can go through and base load them and go through and then use whatever the load unload characteristic of the swing compressor is. That's really the ideal way to go through and run it, for the most part, to run a compressed air system anyways, is to have the most of them base loaded. One of the the specific questions here is on fixing leaks and how would that differ from a single compressor system. For fixing leaks, I don't think that actually would matter, because again, we're talking a demand side. You do want to go through and eliminate all those leaks that you possibly can. I think the only time you ever get into real concern, or if you will, trouble with when you're fixing leaks, is if you ever got it low enough where you have a base load centrifugal that was always blowing off because you got into a too low of a condition. When we talk about going through and doing baselining in for fixing leaks in again in the compressed air challenge training, we'll go through and we'll talk about using load unload compressors and doing a stopwatch on a non-production time to go through and see what the leak load in the plant is, to take your amount loaded divided by the total time, and that'll give you the percentage that you're leaking. If you have multiple systems, I always tell them to go through and lock those compressors in, and and just run on the on the one. The other one is a pump down method, and you would just that's one where you go and calculate the volume in the system, and you go through and take it from line pressure to 50%, and then you calculate how quick it happened and what the rate of fall is. That one you can still do with multiple compressors, because again, you're pumping up the system. You could go through and see how many of the compressors takes it to pump up to the system, and then when you go through and do that drop down on it, it'll give you an idea. But since you're calculating flow, it won't have a big impact on it when you're talking about compressed air leakage. So somebody weigh in on the outside air. This is on the compressors themselves. Shouldn't really say for rotary screws, but again, it's recommended. So I actually went through and again, the oil injected rotary screws, you're right, it's absolutely very little. There's I was talking with Frank, and he actually measured this, and this particular one, he was actually found that change from 40 to 90 degrees only yielded a 2%. Oil-free rotary screws, on the other hand, that one of the manufacturers publishes for every 10 degrees, it's a 2% increase in mass flow. The one reference is to the Handbook of Mechanical Engineering Calculations. That actually showed a calculation using an outdoor temperature of 50 versus 90, and it was about 7.32. So you can see the 7 to 8 that was in the previous one is pretty close. Reciprocating compressors, I pulled an old Ingersoll Rand data book that I had that it goes back into the into the 50s and 60s when it was last updated, but that was when we were using all rotary screw recip compressors, And this shows a table that compared the horsepower saved at 70 to produce 70% shop air. The idea that they were saying is that once the air is out in there, it quickly, after it goes through the process, quickly it gets to the same temperature. So when you're in the air, when you're in the shop, it's going to be in the plant, it's going to be that temperature. So intake air at 40 would save 5.7 horsepower. And if you did it at 90%, it would use 3.8 more. So that same 70% shop air, it's a table that just showed what the savings would be. And then of course the biggest one is centrifugals. They are mass flow machines, so the inlet pressure has a big impact. Again, this has been added into the advanced for showing the calculations and the differences of it. But really, the power is the polytropic head and the total weight flow minus the losses in mechanical and efficiency you have. And just to give an example, compressor rated at 90 degrees inlet temperature will have 17% higher weight flow when operating at 10 degrees inlet temperature. I actually had one where I was doing an engine-driven centrifugal. I was putting a project in, and it was displacing power that the utility was giving us a rebate for power displaced in August. And we were doing the measurements in November and December for baselining. And I was actually working with the applications engineer from the manufacturer, and he came back with his results, and I said, you didn't compensate for the temperature differences between the two. And he said, well, I don't have to do that. I said, yes, you do. Go back and redo it. And he came back and said, wow, it was 12 to 15% difference. I said, yep. He said, how do you know that? I said, because I operated them. I always knew that I'd be able to produce more in the winter. So it can be a significant difference, and it can affect your results when you're talking about certain projects, especially the one I just gave you an example for. So we often get replies that it's too cold. We can't go through and do it. How cold is too cold? And should it be adjusted to 40 degrees? This one again, it depends on the type of compressor. The one that I've heard the most on is for the flooded screws. And the concern there is if you go through and have it shut off and it constantly has outside air going into it, that the oil will get too cold and it'll be too hard to start up. And if you don't have heaters to get it going, you could cause issues and problems there. It may cause a little bit of condensation pieces of it in there too. There's a couple ways you could get around it. You could always go through and put in indoor actual dampers to close off when a compressor's off, to go through and do that. That's the one I've heard the most, and it really is around the maintenance and the oil conditions of it. The rest of the ones for the oil free, they still have a little bit with the lubricant that's there, but that one's more on the temperature of the cooling water and it recirculating all the time. So that's the one that I know of the biggest ones. And yeah, manufacturers won't recommend it because again, they don't want to start it up because of the potential cold oil that you would have. But I would say that there's a lot to be there. And again, for the ones you're talking about, you don't get a lot of benefit for the oil injected rotary screws. So you wouldn't necessarily want to be doing and changing that because it may not pay back as well. For the other ones, I think it will. And if there is certain ones that they're saying, I would definitely check with the manufacturer and see if there's some other way you could go through and get around that so you could still take advantage of this. KGI data sheets, how to read it properly. Really what the KGI data sheets are really just showing you is that they're going through and they're an independent, as you know, they're an independent agency that goes through and just randomly gets the units, and they go through and do testing on it. And what this really will show you is it'll show you the full load, your full load capability, your no load capability, the efficiencies of your motors, and then the total package, what the total package, including if you have an air cooled, the actual fan for the cooler. It'll give you the total package KW that you can see there, and then what the actual rated capacity at full load is. So it gives you the ability and the information just to be able to calculate the savings or calculate the cost of it by putting in the formula and going through and doing run hours times the horsepower and time to, divided by the motor efficiency. So going through and doing that, and it gives you the ability to look at, be able to calculate that out. What it doesn't give you, unless it's a purely modulating machine, is if it has auto dual capability, which means it can be load unload modulating, and then shut off. This just gives you the load unload conditions. If it's switched over in modulation, you're not going to get the actual efficiency of the no load efficiency is going to go through the roof, because it'll be more like 70% of the actual load, because again, modulating machines do not go through and reduce as the load reduces. And then the anisotropic efficiency, that really is just saying how efficient it is to an idealistic compressor that has no losses. So some people think it has a benefit. I'm not sure. I'm convinced that it has something meaningful for people in the plant, other than maybe comparing one to another. But again, that also changes with the conditions in a plant, and so it may be a little bit different. So hopefully that does it. If you look at the VFD one, the difference there is it'll give you at different stages of the VFD, and how it's being driven and what the total package usage is when it's, when that's operating and when that's running. So what types of compressors, control strategies, and what are the benefits of them? The ones we go through and highlight in the training really are, just the normal cascade ones that you have. The cascade itself, is good if you have no controls at all and you have to do it. When you get to about 3 or more compressors working together, cascade, you'll start overlapping. You're going to start having issues with that. The next level they have is a networking control, and that's what you would consider the blue cable, going from compressor to compressor, and the same compressors, doing that. So those would be ones that we would go through and do it. The other ones are sequencers, which can go through and work with multiple different types of compressors, and then of course the full-blown controllers, which would be a master controller like an energy management system. The sequencing of different types of compressors, really that you got to go back to what the type of compressors are. You really have to have the right compressor under the right conditions. And again, we go over all this in the training, but no load does require adequate storage to be efficient and effective. Rotary screws, you want to go through, and they should not be run below 40 to 50% from an efficiency standpoint. Variable speed machines should only be used for trim. They're not meant for base loading compressors. Centrifugals are efficient base load machines, but have limited modulation. So again, you can only turn those down maybe 60 to 70%. In some of the older ones, down 30, down to 60% or 70%. So you've got about a 30 to 40% turn down. Some of the older ones a little bit less, depending on the kind of inlet it has for it. And then the recips have always been efficient, both at part load and at full load. Again, their big thing is more around the maintenance and the people to keep them maintained. So visiting a plant, how can you know the control strategy of a machine be determined? You really have to look at the type of equipment you have. Some manufacturers, have specific characteristics. Some of the machines only came in modulating. Some of them have the ability to auto dual. You'll see switches that'll go through and do that. You can go through and look for inlet valves to see if it is modulating and butterfly valves are moving. You can also go through and look and listen for load unload characteristics if it doesn't say it on there, and say load and unload time. So there's several different ways you could go through and try to establish this. Again, it may be hard if the facility people don't know that. But if you spend time around the machine and it's how it's operating, it should give you a good indication of the control strategy they're using. Which controls should be upgraded on an air compressor system? Really, this one gets driven by what can you actually cost justify and what makes sense, as well as obsolescence, parts not available, just not working anymore, and just not functioning. That's when you'd go through and start looking at upgrading it. I've had situations where I had real old controls that I wanted to upgrade and put in. I had old recips that were running with centrifugals. The problem I had is the centrifugals ran base loaded all the time, and the recips cycled with the old pneumatic controls just fine, and I could never cost justify it. So really, a lot of it you still have to remember has to be cost justified when you go through and put in a control system. VFDs, existing, is retrofitting a load unload feasible and recommended? What's the payback warranty? Variable frequency drive, this is just pulled from some of the compressed air stuff, challenge stuff. But again, the real thing with this one is, can it be done? The answer is yes. Is it recommended? I would say no. And the reason I would say that is because when you go through and design a rotary screw, it's dependent on this part here where you say dependent upon the male tip speed. What that is it's designed for an optimum speed. So when you design a base load unit, you design that optimum speed on that curve to go through and hit at 90%. When you're going through and designing it for a VSD, you're now going through and designing it between 40 and 60 for that optimum tip speed. So when you, on a VSD, when you get to the higher ends, your efficiency drops off. And when you get to the lower ends, it drops off. But on the base load machine, it's at 90%. So when you start lowering it and using a VSD to go lower, it just keeps dropping further and further and further as far as your efficiency goes. So it wouldn't be very efficient to go through and do it. The other thing that VSDs have is when they start getting into a low load condition and a low RPM, the manufacturers will actually lock it out because they found out that there's not enough temperature to actually go through and boil off the moisture in the oil, and it causes problems with the machines themselves. So it isn't recommended. The other thing you always have to keep in mind too, with any putting in any VFD drive, is that depending on the age of the motor, if it has the ability and can take the inrush current that happens, with a VSD. So again, you can do it, but I wouldn't recommend it. Data logging. This one talks about data logging on the VSD and the relationship on it. The thing I guess I'd want clarification here is it looks like the student is going through and doing the measurements at the actual motor itself. When you're going through and baselining a motor, I mean a VSD system, you should never do it at the motor. You should do it to what the drive input. And the reason I say that is that a lot of the drive manufacturers have already compensated for some of the power factor correction and some of the harmonic distortion with filters. And the other thing is what your utility bill is actually seeing is the input to the drive, not to the motor. So the motor piece of it and measuring it there can give you kind of an irrelevant thing. And if it drops too much, I've known of people that have actually fried the CTs with going through and doing that. So you have to really be aware of that when you're going through and looking at the actual power of that. So again, that was the question that was there. And I would go through and make sure you're measuring it in the right place. Miscellaneous pressure flow controllers. This is a good synopsis of whether it's good, whether it's bad. You have people that are very pro, you have people that are very con to it. Me, I'm in the middle. It has to cost justify. You're running at a higher pressure. For every 2 PSI, it's 1% efficiency. You need to make sure that it's justified. If you have systems that have major swings in demands and you're really causing you issues, you may need to go through and do this if you can't go through and correct the demands. Me, I prefer to go through and correct it at the demands because this is just kind of curing the symptom and not the disease. But they are very good and they can be used, especially if you need to maintain constant pressures. That may be in areas too, like pharmaceutical and food, where they've got FDA regulations and their pressures are critical. Those may also be a reason why you might go through and do it. The other thing is that plants change over time, and these are sized for plus or minus 20% of the load. And in the auto industry where I was at, where you're going through and ripping out all lines, and you may start from scratch, it becomes disposable equipment, and it may not be it. So again, it's got to cost justify itself. Substantial water in a surge tank guidelines when to add more dryer capacity. I'd look at the entire system and find out what's wrong with it. First of all, does the surge tank have a trap on it, and is the trap failed? Because even with a good dryer, over time it could go through and do it. Where is it actually located, the surge tank? If it's obviously if it's a wet tank or a control tank that's before the dryer, it wouldn't even have any impact. You really need to just be aware of that piece as well. The other thing is you may have some small leakages that may happen in if you have water cooled intercoolers and aftercoolers. You may have some carryover that you could get with when machines are shut down and things like that you have to be aware of. So it isn't just about the drying capacity. It's really about it's really about what's causing the water and where it is. As far as the dryers, I would look at things like pressure drop across the dryer. If it's gotten too large, too big, the dew point, if you're seeing dew points way high and issues there, then I would start looking at the dryer. Or if it's a if it's a fixed load dryer, where where you've got low flows through it, that could cause an issue as well. And then how do you decide to run compressed air line when it's too long and have compressors at the both end of the plant? This really, you should look at the pressure drops and where the systems are. Again, this is going to be something you'd want to go through and look at calculating. Is it going to be cheaper to put compressors on the backside of the plant to go through and feed it if you have expansions, or is it going to be cheaper to upsize or run a secondary line and tie it in? So this is again going to be on the pressure and the amount of it. Again, you can use the rule of thumb of 2 psi equals 1% efficiency. So if you got a plant that has 10 or 15 pound drop, and you can go through and cut that back, in half, that's going to be anywhere from 5 to 7% savings on your actual horsepower that you have put in. So that when it's affecting production, you need to do it, because the other things you need to look at in that system is, are you having major pressure swings that's doing it? Is it intermittent demands that are doing it? Can I go through and attack those? So there's a lot of things that will fall into this before you would go through and look at the airlines and upsizing them. I gotta be mindful of time here, so I'm just going to zip through these so we still have time to go through. So some of the other things that I wanted to just highlight were the demands, the maintenance, and the awareness. So again, these are things that we also cover in the training. Just want you to be, kind of a reminder, because these are big areas that you can go through and find a lot of improvement, and not at a very high cost. So going through and addressing these and being able to do things like lower system pressure and get rid of those inappropriate uses is really a good piece. This just shows again the conversion on the inappropriate uses. Why do we want to do it? A compressed air 1 horsepower motor costs you $2,330 to run versus $390 in electric. So doing these conversions can save a lot. Leaks, you guys know about leaks and all the problems that it can cause. This is just, again, showing the leak itself and some of the other things it does. Just letting people know again that that's a costly thing, and that 2% equals 1% efficiency. Again, if you could go through and do a 100 horsepower running at 80, you'd be able to save 6,500 per year. And then the maintenance losses, we go over this in there too, but this is just some pressure drops across filters, inlet filters. The maintenance is a necessary evil, and that's a big part of my background. And it does bother me when that's the first thing that's cut, but it is something that you really can go through and take care of. And then, this is just about hosting. If you're going to go through and look at, working with the IACs on hosting it, some other reasons that we have, along with the thing being strong, why would be good for us to partner together and to do more training together. that, you know, people, this is just showing about awareness. This is, if I told you you could reduce compressed air by buying jackets, hats, keychains, and pizza, would you buy it? Well, that's what the Ford Monroe plant did that we did. They had an hourly team. They gave away all of the buttons, keychains, t-shirts for getting air leaks fixed, and also for passing the red coat energy audit. They posted leak boards, and they used the communication network. The result, they, you know, you can see they had huge results on what they used per day. The non-production usage dropped from 54 to 600, so it was huge. And then $2,000 per day savings, and it changed an entire culture and awareness. And this is just to kind of give you guys a idea of the importance of awareness, and what it is and what you'd want to do in an awareness training about being, you know, targeting the operators, site specific, understanding the demands, and that they're the key to it. And the compressed air challenge I mentioned, we do have that. This is just you know, the awareness training. It's really customized elements. It's based on all the site information with site pictures. It's meant to be like a toolbox safety talk, 30 to 45 minutes depending on it. And again, it's flexible on how it's done. We have instructors that are across the entire area, so we can go through and regionally help with training on that. And so it is a good way to co-brand the events and to be able to go through and assist you with setting it up. And I did want to also mention real quickly the CAGI certifications for those of you that may or may not know. CAGI, Compressed Air Gas Institute, has now developed 2 personal certifications. The first one is the system specialist, and the body of knowledge for this test is based on is the fundamentals advanced course, the best practices manual, and the CAGI handbook. And then they're working on, you know, they're in beta right now with the certified compressed air system assessor, and we will be working with them to develop it because they've got it certified to ANSI standards. So when you go through and do that, you have to have the training and the certification body separate. So it's a joint effort. We're working to develop that. And so again, just taking the systems approach. For those of you that, you know, to get more information, you can go to the website or get a hold of Tracy. And then I'll have any additional questions now. And I'll also just kind of throw this up in case you guys want to get a hold of me and have questions after this, because I know it's being recorded as well. So with that, I'll go through and start turn it back over and for any questions you may have.
Thanks, Joe, for your presentation. We had one question in the chat from David Goodman from IUPUI. He was asking, what would it cost, space and money, to host a compressed air challenge session?
Okay, good. That's a good question. So the compressed air challenge training to do that would go through, and it would be it's the instructor cost and any travel that would be there. So for a fundamentals, it's one instructor for one day at $12.50 for the day, and any travel costs that might be there. And then you have to get the manual and the best practices manual and the course manual. And I believe for both of those together, I think it's around $110 or $120 for both of those per student. That would give you an idea. And then of course, whatever you'd have for the hosting of the site, and if you were doing lunch or any of that other stuff. You can go on Compressed Air Challenge website, and there's a hosting kit that goes through and gives it, and actually has a calculator. You can go through and do it. For the advanced, it's 2 instructors, 2 days. So the cost of the instructors is a little bit is more. It's $5,000 for the instructors, and it's about, I think, about $70 a manual per person. And of course, the instructors would also have travel. We are doing the web edition right now, and that one, because of obviously with COVID and everything going on, that one we're not requiring to do the best practices manual. They get a digital copy of the workbook. And the cost of that is the same for the instructor, $12.50. And then I think it's $40 for the digital and $10 a person for the, for the actual student. Yeah, those are what I'm remembering from off the top of my head. But all of that information is on the website, for the compressed air challenge website here. And you guys can go get all that information as well, and and what that cost is.
Thank you for that. We have another question from Joe Junker from Oregon. What do you think about compressor VSD retrofits if not operated below 50% speed?
I think I think that the retrofitting of it, if it's not below 50%, you're going to lose some efficiency, again, because they're meant and designed to do it 90% of the full load capability. So you are going to lose some efficiency on it. I would really look at the overall cost of the drive and the efficiency you're going to get and the difference between them. The other thing I take into consideration, especially from an end user perspective, is the age of the equipment and what you're retrofitting. And is there still going to be a possibility that they're going to have major maintenance and overhaul on it, either on the air end or the motor itself? Because again, you may be throwing out good money out to bad, and it might just be worthwhile bundling it up into one. So, and I'd love to give you a clear-cut answer, thumbs up, do it, nope, thumbs down, don't do it. Really, it depends on the situation and the structure and the cost, because again, it even depends on cost of electricity, where you may have somebody at a real high cost of electricity versus, low cost hydropower or something like that. That you may run into. And if that's the case, then there's no way you would, you wouldn't be able to cost justify as much as you would. So that would be my answer. And I hope that answers the question. If not, please let me know, and I can elaborate a little bit more on it.
I think that answered Joe's question. Does anyone else have any other questions? Anything related to the compressed air challenge? All right. I don't think we're getting any more from the chat or from our attendees.
Well, I guess also it's a Friday too, right? So.
All right. Thank you, Joe. Sidika, do you have any closing words?
Oh, I think you guys had it covered. So we've given back about 6 minutes back to you guys. Have a great weekend. And thank you, Joe, for taking the time and going through this presentation.
Thank you. And thanks again for having me. And again, look forward to working with all of you and the Compressed Air Challenge and the IAC's continuing our relationships that we've had over the years.
Appreciate it.
Thank you, everyone.
Thank you. Bye, everyone.